begin. Welcome, grade 7s. It's really awesome to have all of you here with us again this Monday afternoon. We're about halfway through our course on number patterns. And of course, once this course on number patterns is finished, we're going to be starting another course on functions and relationships. And then when that's done, we're going to start doing some revision for your exams. Okay, so it's really nice to have you all with us again. And to those people that are new here and here for the first time today, we welcome you to Watobe, and we hope that you'll be really, really happy here with us. Just a reminder, everybody, okay, there's no bad words that are going to be used or put in the chat. Okay, we've had that in the past and we're not going to tolerate that sort of behavior. So no inappropriate language or words in the chat, please. And use the chat appropriately, okay? It's there for you to ask questions. It's not there for you to distract other people and behave badly. Okay, you're supposed to be asking Kat and I questions about maths. We're not supposed to be chatting about the weather and what we did on the weekend or that kind of thing. Okay, all right, so let's get underway. Unfortunately, the last time I was a little bit ill, so Kat took my lesson, which is awesome. Thank you so much for doing that for me, Kat. And today, what we're going to talk about is making rules for number patterns. So I'm hoping that today's lesson is going to be interesting and also a little bit challenging. And I want to start off talking about a pattern of numbers that I think is fairly easy for us to use an example on how to make the rule. Okay, so now when we're talking about making the rule for the number pattern, we can either talk about making the rule in words, or we can talk about how we would make the rule using mathematical language. And it's important for you to obviously be able to write the rule in words, but it's even more important for you to be able to create the rule using mathematical language. Okay, so when they give you a number pattern like they have done here, so I've said consider the number pattern 4, 7, 10, 13. Did anybody know that what we're actually looking at, okay, is that the first term in the pattern is 4. And the second term in the pattern is 7. And the third term in the pattern is 10. And the fourth term in the pattern is 13. And then the pattern continues on and on and on in the same way. All right. So what that means is that 1 goes in and 4 comes out. And 2 goes in and 7 comes out. And 3 goes in and 10 comes out, and 4 goes in and 13 comes out, etc., etc. Benolo, I see you've raised a hand. What's up, Benolo?
Ma'am, I raised my hand if we have to answer some questions.
Oh, okay. All right, that's fine. So we're not going to answer a question just yet, but I'll ask you when it's time. Okay. All right.
Okay,
okay, so now, in fact, you can answer this question, Benolo. When we are looking at these numbers, 4, 7, 10, 13, all right, what sort of pattern is that? Is that an arithmetic pattern or is it a geometric pattern? We were talking about that the other day. Do you know? And do you know how you...
I think it's, I think it's arithmetic because, ma'am, we are adding.
Absolutely, that's really good. Okay, well done, Benolo. Okay, so it's arithmetic because each time when we go from one term to the next, we're adding. Okay, and how much are we adding, Benolo? We are adding?
Ma'am, 3.
3 each time. That's really good. Okay, so then in order to get to 10, we've got to add 3 to 7. And in order to get to 13, we've got to add 10 onto 3. That's perfect, okay? So what I want to show you today is how we can generate these numbers using a rule, all right? The number that is our difference is used as a multiplier. So this number over here, 3, this becomes, excuse me, our multiplier. So in other words, what happens is we do this. 1 goes in, okay, so this is 1 going in. We times it by 3, okay, but we get out the number 4, right? So the thing is, 3 times 1 doesn't give us 4. So that means there has to be something else happening here. And in this case, we're having to add on an extra 1. Okay, so in order to generate our pattern, we're going to take our difference and we're going to multiply that by our input. Can you see here how the number that went in is the same as the term number? Okay, so in term number 1, 1 went in. In term number 2, 2 is going in. Okay, so 3 times 2 gives us 6, but we don't get 6 as our output. Our output is 7. So what do we need to do? We need to add 1 again in order to get our answer of 7. Okay, so now I'm going to ask one of you what we would do to create term number 3 in this pattern. Okay, so Anati, your hand is up first. Anati, how would I create term 3 in this pattern using these rules or this rule?
I'd have to say 3 times 3 plus 1.
3 times 3 plus 1.
1.
Good. And that's how we would end up with
10.
10 as our answer. Okay. So
Ma'am?
now this, yes.
I forgot what arithmetic and geometric, how to tell the difference.
That's fine. Okay, so when a pattern is arithmetic, it means, okay, I'll tell you what, instead of me telling you, let's see if we can ask someone else, see if someone else remembers. Hold on. I'm going to ask Takalani. Takalani, can you remember the difference between an arithmetic and a geometric pattern?
Yes, ma'am.
Okay, so Takalani, explain to us, what's the difference between arithmetic and geometric?
So, ma'am, the difference between arithmetic and geometric is in arithmetic pattern, you add and subtract a number, and in geometric pattern, you multiply and divide a number.
That's it. Well done. Well done. That was really, really well explained, Takalani. Thank you. Okay, so in all arithmetic patterns, in order to get to a subsequent term, we are either going to add or subtract the same value. When it comes to a geometric pattern, as Takalani said, we are going to multiply or divide. Okay, so in this case over here, because this pattern is seen as arithmetic, because we are adding 3 each time, we would say that the constant difference is 3. Okay, so if you recall, all arithmetic patterns have a constant difference. Geometric patterns don't have a constant difference. They have a constant. Can anybody remember what that was called? Let's see who's got a hand up. Tenji, what do geometric patterns have? A constant?
I think it's a constant ratio.
That's right, a constant ratio. Okay, because we are multiplying or dividing. Okay, lovely. Well done. That's great, guys. All right, so our constant difference becomes our multiplier, right? And in this case, we see that we multiply our input by 3, we add 1, and we end up with our output. Now, what's useful about being able to generate a rule like this means that instead of us having to go, okay, well, now for the 5th term, we're going to add on another 3, which means we've got 16, and then it would become really, really difficult. I mean, imagine if we wanted to know what term 100 was, and we had to keep on subbing in 6 and then 7 and then 8 and then 9 and then 10. We'd be here all day, wouldn't we? So the beauty of knowing what the rule is for the arithmetic pattern means that we can work out our answers a little bit faster. So now let's see who's got a hand up. Okay, Intikelo, I want to ask you a question, if that's okay. If I wanted to work out the value of the 20th term of this pattern, what would I do, Intikelo?
I'll say 3 times 20.
That's it. So 3 times 20, and then what mustn't we forget to do? We've still got to remember that we have to add
1.
That's it. Okay, lovely. So in this case, the 20th term is going to be equal to
21.
61. Okay, remember you've got to say 20 times 3 plus 1. Okay, so that will give us 61. Okay, good. Well done. All right, Chidiso, I'm going to ask you the next question. How would we work out term 100? Chidiso? How would we work out term 100? Okay, Chidiso's not talking to me. Okay, Buhle, how would we work out term 100?
Ma'am, so first you are going to say for term 100, it's 3 times 100.
3 times 100, good.
Plus 1, which is
Plus 1, which gives us 301. Absolutely. Okay, so this is easy for you guys. Everybody seems to be managing with this. Well done. That's really nice. Now I want to ask you a question. All right. If I now want a rule in terms of n for my pattern so that I can work out any term in my pattern, how am I going to do that? So remember, term number n goes in. So that means I have to take my difference, multiply it by n, and add 1. Okay, so this is what is known as the rule for the pattern. And when you go to high school next year, they also refer to this as the nth term. Has anybody heard their teachers use that word before? The nth term for the pattern.
Yes, ma'am.
You've heard them use
Yes,
it. Okay,
no,
there we go.
ma'am.
So
No, ma'am.
you haven't. All right, well, that's okay.
Never, never, never.
This time, that doesn't matter. Okay, I want to ask you another question. If I chose to write it like this, is that okay? If I write Tn as n times 3 plus 1, am I allowed to do that?
No.
Why not, Anati?
You will get
It's because you can't times I think it's because you can't times, you have to times 3 with the I forgot what it's called.
You have to times 3 with the n.
Yes.
Okay, but I am timesing the 3 with the n. Okay, so it actually doesn't matter. It makes no difference if I write it like this. But you'll see when you go to high school, and I'm sure those of you with maths teachers who are trained to teach high school, I'm sure they would say exactly the same thing. When you get to high school and we have a letter and we want to multiply the letter by a number, what we do is we write the number in front of the letter, and that means times. Okay, so if I have a letter like X and I want to times X by 5, I write 5X, and that means 5 times X in mathematical language. So it's exactly the same thing with this. All right, so instead of writing it as n times 3 plus 1, all mathematicians would write this as 3n. That means 3 times n plus 1, like so. Okay, but it is nice for you to write it in this way with the number in front and the letter behind it, because then you're getting ready to go to high school. Okay, and that's what your teachers next year will teach you how to do. Okay, so now that I have found the nth term for this pattern that was on the board, I want you guys to try and find the nth term for a pattern that I'm going to give you. Now, when I say the nth term, what I'm talking about is what I did here in purple. Okay, this is the nth term over here. Okay. All right, so now the first pattern that I'm going to give you to find the nth term of is number 1. If you finish number 1, you can try number 2, but I want everybody to start at number 1. Okay, so we're going to make an nth rule using those numbers. And Kat and I are going to be quiet for a little bit and let you guys concentrate on that. Okay, Tabang, I see you've got your hand up.
Oh, sorry, ma'am, it was a mistake.
Oh, okay, Tabang, no problem. Okay, Anati, I see your hand is up. What's wrong?
I'm done.
Have you done both of them, Anati?
Yes.
Okay, all right, 2 seconds. Just let everybody else finish and then we can carry on with another one.
Okay.
Okay, Bootley, are you done?
No, ma'am, I'm just a bit confused on question 1.
Okay, what's confusing you?
Ma'am, I'm confused with how to get to the next number for number 2. So number 10.
Okay, you don't have to get to the next number. What I want you to do is make the nth term for the pattern, just like we were talking about up over here. Okay, so like the nth term for this pattern was 3n plus 1. That's what I want you to do with these patterns over here. I want you to make an nth term.
Oh, okay.
Okay.
Okay, now I understand. I thought we were supposed to figure the whole sum.
No, okay, we're just going to make the nth term.
Okay, thank you.
Okay, no problem.
Ma'am,
Yes, Anati.
so would I have to write like an for example, 1 times n plus 3?
Yes, but when you write 1 times n plus 3, you've got to write it in the correct way, all right? So if you write 1 times n plus 3, then you would write that as 1n plus 3.
I just wanted to make sure if I was right.
That's fine. That's fine.
Thank you.
Okay, no problem. Okay, so it seems like there's quite a lot of you that are finished already. Asemahle, what did you get as the nth term for pattern number 1?
It's 4n plus 2.
4n plus 2. Okay, and Asemahle, can you tell me how did you get 4n plus 2?
Ma'am,
What did you do?
I draw like a diagram, like the way.
So a diagram that looks like this one.
Like a square.
Okay.
No, rectangle.
Okay, but you're quite right. That's 100% correct. So you said 1 went in and 6 came out, and 2 went in and 10 came out, and 3 went in and 14 came out. So you took 4 and you times it by 1. But it's not 4 that comes out, it is 6 that comes out. So that means you had to add 2. So you're quite right. Okay, and then 4 times 2 is 8, plus 2 gives us 10, etc., etc. So that is perfectly correct. Okay, you got Tn equals 4n plus 2, and you are right. Good job, well done. So anybody else who got that as an answer, that's also correct. Good job, that's really nice, well done. I thought you guys wouldn't know how to do this, but it seems your teachers at school have done a very, very good job of teaching you, and you all know exactly what's going on. Well done. Okay, now, Bulela, why can the rule not be n plus 4? Why can the rule not be n plus 4? That's a common mistake that people make. Okay, the rule can't be n plus 4. Okay, that's because we are talking about input and output. Okay, one goes in this particular case over here, let's just stay with this question. 1 goes in and 6 comes out. So n are the numbers that go in. Tn are the numbers that come out. So 1 plus 4 is not 6, and 2 plus 4 is not 10, and 3 plus 4 is not 14. It's a system of input and output. Okay, so yes, you're adding 4 to go from one term to the next, absolutely, but that's not the nth term of the pattern. Okay, you've got to calculate the nth term of the pattern like I've just showed you here on the left. All right, let's have a look at number 2 now. Okay, let's see who's got their hand up. Okay. Mojalifa, did I pronounce that correctly? Mlambo?
Mujalif.
Mojalif. Okay, sorry,
Yes,
I
ma'am.
apologize
You
for
pronounced
my...
it.
I'm sorry. Okay, all right. Do you want to tell us how you worked out the answer for number 2?
No, actually, I want to say that I'm a bit confused when it comes to the letters.
Okay,
But
that's
I'm
fine.
just like a bit confused on that.
Okay, all right, we go through it again. That's not a problem, don't worry. Okay, let's see who else managed to work out this one. I'm going to ask, okay, Anati, what did you get?
Ma'am, I said since 10 you would get you would add 8. I said 8 minus 10 is 2, so I think that's where you started from. And then I said so it would be 2n plus 8.
Almost, you just got it the other way around. Okay, so remember, the number that is your constant difference is going to become your multiplier. Okay, so 8 becomes your multiplier. 8 becomes your multiplier. So in other words, what happens here is 1 goes in. So for term 1, 1 goes in, we times it by 8, but we don't get 8 as our answer, we get 10 as our answer. So that means we've got to add 2 in order to get to 10. Okay, and when term 2 goes in, we take 8, we times it by 2, we get 16, we add 2, we get 18 out. Okay, so term 3, when 3 goes in, we take 8, we times it by 3, we add 2, we get 24. From 3 times 8 plus 2 gives us 26. So that means, grade 7s, that when n goes in, Tn, when n goes in, we take 8, we multiply it by n, our input, and we add 2 to get any term in the pattern. That is going to be our nth term. If you got that correct, can you just put a thumbs up in the chat? And if you didn't get it correct, can you put a thumbs down in the chat just so I can see how you guys are doing?
Ma'am,
Yes, Anati.
for the worksheet for question 1 at the bottom, I've done it. I did it today at school.
Oh, really?
Yes.
Oh, wow. Okay. So your teacher and I obviously decided that it was a good resource.
Ma'am,
Yes, Mojalifa.
Teresa's hand is up.
I'm struggling to hear you.
Oh, I think Sidiso
Ma'am,
is new.
Teresa's
He
hand is
has
up.
a question.
Oh, Tsidiso's
He's been
hand is up.
struggling
Oh,
a
and
bit,
I
yeah.
see Aaron's also got a question. All right. So I'll take the question now. Aaron, when you say where does the 2 come from? Okay. Are you talking about the 2 that we have to plus here?
Yes, ma'am.
Okay, all right. So what you are doing is that after you have taken your first input, which is 1, and you've times it by your multiplier, if you don't get the number that's there in the first position, so 10 is in the first position, you have to plus or minus to get that number. So that's why we said we're taking 8, our multiplier, we times it by 1, 8 times 1 is 8. But in order to get to 10, I have to add 2.
Oh, thank you, ma'am.
Okay, so it's not just that pattern. We're going to have a look now at other patterns where something different is added or something could even be subtracted. Okay, so I'm going to show you a pattern like that right now. I just wanted to see where everybody was with this. Okay, so for some people it's going really, really well, and for other people it's not going very well at all. Okay. That's fine. Tell you what then, instead of going on to that one, I've got others under here that I wanted to do, but those are a little bit more difficult. So what I'm going to do is I'm going to go over here and we're going to look at another one. Okay. Okay, so let's just put this up for you. Okay, so now let's look at this pattern of numbers over here. Right, so we've been given a pattern. The pattern goes 3, 7, 11, 15. That means that 1 goes in and 3 comes out. And 2 goes in and 7 comes out. Another way for us to be able to visualize this is like this. You've seen these spider diagrams at school. So there is some kind of rule where 1's going in and 3's coming out. And 2's going in and 7's coming out. And 3 goes in and 11 comes out. You've seen these at school, haven't you? And 4 goes in and 15 comes out. So what we're trying to do is we're trying to work out what is the rule? How is the number going in being operated upon in order to give us the numbers on the right-hand side, the outputs? Okay, so these are in your inputs. And here is Tn, your outputs. Okay, so for all of those of you that were in Tekelo, you're right. You're adding 4 to go from one term to the next. But what are we going to do with that 4 in Tekelo? That 4 becomes our what? Not our rule. What are we going to do with that 4?
Divisor. Ma'am.
Masizazi?
I think our 4 becomes the constant difference.
Our 4 is the constant difference. Okay, so what we have to do here is we have to take that 4 and we have to times it. Yes, Tenji, with what? What are we timesing the 4 with? With n, quite right, Nima. Okay, so we've got to times it with n. So in other words, we are going to get term 1 of our pattern by taking 4, our constant difference, and timesing it with our first input, n. Okay, now have a look here. Who was it that I think had this question? I think it was Erin. Okay, so Erin, is 4 your first output? Is 4 your first output? No. Okay, your first output is 3. So now, in order to get 3, we need to balance this by taking away 1. Okay, so now for term 2, again, we're going to take our 4, times it by our next input. When we take away 1, then we end up with 7. So that means that the nth term, when n goes in, the nth term of this pattern is going to be times input by 4 and take away 1. Okay. All right. So that's fine. Okay. So now we're going to go and have a look at something that's a little bit more difficult. Okay. Because sometimes what can happen is that the number that we are taking away, our constant difference, isn't always going to be a positive number. Okay, so I'm just going to rub that out. I'm going to move this down.
Lee?
Yeah?
Please ask Sidiso his question. He really
sorry.
wants to ask.
I beg your pardon. Sidiso, go for it. What was your question? My apologies for making you wait.
Ma'am, you see, ma'am, that question, ma'am, the one of like that number 8. When you get that 8,
the one that I
like,
just rubbed out.
Yes, ma'am.
Yes.
Ma'am, when you get that number, ma'am, do you multiply it?
Yes, absolutely. So the difference between the terms is your multiplier. Okay, so here, term 2 minus term 1 is 8. Term 3 minus term 2 is 8. So now 8 is going to be the number that you use to multiply your input with.
Okay, ma'am. Thank you, ma'am.
Okay, no problem. All right, so now we're going to see what's going to happen here with this one, with the next ones, where it's now going to be a negative number. Let me just move this down. Okay, so now we're going to look at question number 3. Okay, our first term is 5. Our second term is -1. Our third term is -7, and our fourth term is -13. What's happening to these numbers, grade 7s? Are they getting bigger like they did in number 1 and number 2?
No.
No, they're getting smaller, aren't they? All right, so
Yes,
Devin, how much smaller do the numbers get each time?
6.
They get smaller by 6, but would I say that the constant difference is 6, Devin? Would I say the constant difference is 6, Devin?
No.
No. Okay, so Rolivua, what would I say that the constant difference is?
The constant difference is -6.
Is -6. Absolutely. These are integers. Quite right. Who said that? Yes, quite right. Yes, well done. Quite right. These are integers. So each time these numbers are getting smaller by a difference that is negative. Okay, so now if we want to work out the nth term of the pattern, do you think that because there's a different or the sign of the difference has changed, that we're going to do the answer in a different way? We're not. We're still going to work out the nth term in the same way. So in other words, what we've got to do is we've got to write down term 1. And then I've got to take my -6, my difference, and times it by my first input, which is 1. Okay. -6 times 1, 10G, is going to give me how much?
About 5.
But is -6 equal to 5? Am I writing the truth here? Why have I left a gap here? I've left a gap because something needs to go in there. All right, what needs to go in there to make it balance? Because it's not balanced at the moment. Indanako, what needs to go in there?
+1.
+1. Who agrees with Indanako that I can balance this by putting +1 over here? Is Indanako correct? Let's see what you say on the chat. Is it okay to put in +1? What do you think? Put your answer into the chat. What do you think, guys? So now, so some of us are saying yes, some of us are saying no. Okay, I want to ask, Luzuko, you said no. All right, so if you're saying no, what's happened here is wrong, and Danako is wrong. What would you rather have done? Luzuko, what do you think the correct thing is? Okay, maybe Luzuko is scared to talk to me. James, I see you've got a hand up. James, what do you think? What are we going to do about this +1 here? Do you think it's okay? Do you think it's not okay? Do you have a different suggestion? Oh, Patson. Can everybody see what Patson's done? Look at have a look in the chat, guys. Patson says, ma'am, is it +11? Patson, your integers are very, very good. That's lovely. Well done. How did you work out that it was +11, Patson?
Ma'am, I started from -6 and then I added up to 5, ma'am.
Absolutely. So what we could do is we could go back and talk about our integers, all right? And we could say, okay, well, here we've got -6. We want to get to 5. So that means we've got to move to the right-hand side. If you guys are going to whistle and make inappropriate sounds, you're going to get kicked out of the lesson. Okay, and then you're going to be very sad because you're going to miss out on all of this. All right, so here we are sitting at -6, -1, oh, sorry, 1 times -6 is -6. Now we want to end up at 5. Okay, so Patson says we need to jump. Let's choose a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. Well done, Patson. Okay, that was perfect. That's exactly what we were looking for. Well done. That's really good. Okay, so now this rule is the rule. Let's just write the second term. So -6 times 2, that gives us -12. And if we have -12 and we +11, we're going to end up with -1, which is our second output. Okay, so yes, we really are working with integers here. So Patson, in terms of n, can you tell me what the rule is, since you were the one that worked out the difference was 11 here?
Ma'am, it would be -6n plus 11.
Wow, Patson, that's excellent. Well done. That's really, really good. Okay, nice job. Okay, so now time for you guys to try another sort of more difficult one on your own. Okay, that was very well done, Patson. Okay, let me move this out the way because it's underneath here. Okay. Okay. All right, so now we're going to have a look at number 5. Okay, so you guys are going to work out what the nth term is. And then once you've got the nth term, then you can put your hand up. Okay, but that's not the pattern. Okay, Chidiso, that's not the pattern. Okay, remember you're writing the nth term, you're writing the rule. Okay, so that's just part of the answer. It's not the whole answer.
The whole answer.
Okay, so we've got to write everything, got to write it as Tn equals. Okay, in terms of n. Then you finished. So again, everybody that's putting answers in the chat, that's only part of the story. You're not telling the whole story. Remember, we want the nth term.
Ma'am.
Chidiso?
Ma'am. Ma'am,
Yes.
so you see, ma'am, after you got that -8, ma'am, because they're saying in the chat, ma'am, they're saying Tn plus 8.
I know. And that's not right, is it?
Yeah.
Okay, so we can't possibly have a pattern that goes Tn equals plus minus 8n. Okay, because how do we know what to do? Are we supposed to be timesing by plus 8 or minus 8? So that's definitely not right. Okay, there can only be one sign.
Ma'am,
Yes, Masizazi.
ma'am, we're doing number 5.
We're doing number 5, but people keep telling me only half the story, Masizazi. I want the whole story.
Yeah, they're not giving us a chance. They're only putting in the chats wrong.
Absolutely. But don't worry, they haven't told you the whole story first. So you work it out.
Yes, ma'am.
Ma'am.
Mm-hmm.
Ma'am, for number 5.
Yes.
Ma'am, isn't it 1 minus? Ma'am, I think it's related to -8.
It is. Absolutely, it is related to -8. But as I was saying, that's only part of the story. Okay, so I don't want part of the story. I want the whole story.
Ma'am, don't you plus -3?
So if you're plussing -3, are you plussing 3 or are you minusing 3?
Minusing 3.
See, now you're starting to think, Tabang. Sounds good. Okay, Erin says 8n times 1. But Erin, are you telling us that 1 times 8 is -11? Does that sound right?
Ma'am.
Ma'am.
Yes.
Ma'am, I think I got the answer.
Okay, Takalani, tell me what you've done.
Ma'am, I said Tn is equals to 8 plus 3.
Okay, but now you don't have an n in there, Takalani. There's no n. Where did n go?
Ma'am, n.
Yes, n's supposed to be in here where I've just drawn a box. There's supposed to be an n in there. Okay, so something's gone. So Indanako is saying for term 1, let's just have a look at this. Indanako says -8 times 1 plus 3. Okay, so Indanako, if you take a number like 1 and you times it by -8 and plus 3, what are you going to get out? Are you going to get out -11?
No.
No, there's -8. So if I add 3, remember I'm going in that direction. So -7, -6, -5, -4. So if I'm sitting here and I go 1, 2, 3 places to the right, I'm going to get -5. I'm not getting -11.
Ma'am.
Someone's actually already put the correct answer into the group.
Okay. Ma'am.
Just hang on a second. Don't shout out, guys. All right. Rangoa, if I pronounced that correctly. Yes, you've got the right answer. Well done. Okay, don't cry, Tenji. It's fine. I'm going to show you now how we were supposed to do this one. It was supposed to be a difficult question. Okay, so you guys were onto something when you were talking about the -8. But the difference can't be -8 and +8. It can only be one number, okay, that you are either adding or subtracting every single time. And that number can't change. Otherwise, it's not a constant difference, is it? So here, when we go from -11 to -19, we take away 8. And when we go from -19 to -27, we take away another 8. And we go from -27 to -35, these numbers keep getting smaller. Okay, so we take away another -8. That's really good. That means that term number 1 is going to be calculated by taking our difference and making it our multiplier. And we have to multiply it by 1. And then we've got to do something to it so that we get -11. So now we are on the number line, and here we are at -8, and we want to get to -11. So are we plussing when we get to -11, or are we minusing? We're going in that direction. We are subtracting. We are hopping 1, 2, 3 places to the left. So that means that we are taking away 3. Okay, are you guys finding the difference? and then writing term 1 and working out what you have to do the way I've shown you, or are you guessing? You've got to use this method because it's going to work every single time. All right, so now we've got term 2. We're going to take our multiplier, -8, and we're going to times it by 2 because we all know how to multiply integers now. That gives us -16. And when we're sitting at -16 on the number line and we move 3 places to the left, we will indeed get to -19, just like we have in our pattern. All right, and if you wanted to test it another time, you could if you wanted to. -8 times 3 would give us -24. And then if we moved 3 places to the left, we would get to -27. So this pattern is n goes in and we times it by -8. And then we take away 3. Okay, this was a difficult question. Do you see what I mean when I said you are only telling me half the story? Okay, -8 is only half the story. Okay, you've still got to work out what we were adding and or subtracting after that. Okay, yes, Sotelo, we're going to do the poll today. We'll do that in a couple of minutes. I just wanted to show you something else before we did the poll. Chidiso, do you want to ask a question?
Yes, ma'am.
Okay, what's your question?
Ma'am, so like when you say term 3, ma'am, if you say that term 3, ma'am.
I don't know. What are you asking me, Chidiso?
Ma'am, when ma'am over here, ma'am, on the question 3, ma'am, when you say term 3.
Yes.
Ma'am, so ma'am, you say -8, then you put the 3, so it's basically 3 times 3, and 3 times 3 is 9, and 9 times 3 is 27, ma'am. So that's how you get your answer.
What you are doing is that you are taking the numbers that go in. So remember, okay, 1 goes in and -11 comes out, and 2 goes in and 19 comes out, and 3 goes in and -27 comes out. So these numbers over here that I'm highlighting in blue, those are the ones that go in here. And that 2 goes in here, it goes in there. Okay, and this 3 over here, it goes in here. -8 is your difference, and that becomes your multiplier. So the difference between the terms is what you are timesing each input, highlighted in blue, by. And then in order to get the answer that actually then comes out, you either need to add or subtract. In this case, you had to subtract 3 each time to get your answer. That's what's happening. Okay, so you've got to look at it as though 1 goes in and this comes out, and 2 goes in and this comes out, and 3 goes in and this comes out. It's an input-output relationship. Okay, input-output. All right, okay. So now let's go and have a look. I think we'll only have time for maybe one of these. All right, but I want to see who's really clever and who's been paying attention all along. Okay, so now if we have this number pattern that I put on the board, all right, and here are our outputs. The first output is 1, and the second output is 4, and the third output is 9, and the fourth output is 16. Can anybody tell me what the rule is in terms of n? What do you think the rule is? I see some hands have gone up. Okay, Ndanako, what do you think the rule is?
For the first one, it's 1, and then 4, you add 3. Then from 4, well, they're basically perfect square numbers.
There we go. There we go. So what's going to be the rule in terms of n, Ndanako? The rule is going to be? This is a difficult question. You said they're square numbers. That's quite right. So 1 goes in, and what do you do to it to get 1 out? You?
Square it.
Square it. And what does squaring mean? When you square something, you are multiplying it by its?
12.
Exactly. All right. So when I take n and I multiply it by itself, I end up with n
squared.
There we go. Good. Okay, so this rule is a little bit different. This rule is n squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if I wanted to work out what was this term over here, term 100, I could do the same thing. I could sub in 100, and that would be 100 squared. And can Anati, tell me, what is 100 squared? Do you know? Can you work that out without a calculator?
It's one.
It's 100 squared.
So it means 100 times 100. So we don't need a calculator for this because it's going to be a 1 with 1, 2, 3, 4 zeros afterwards. Okay, so 10,000. Yes, Anati?
Were you saying me?
I think I did say you. Anyway, it doesn't matter. It's fine. Okay. Oh, look at that. We've run out of time. We need to do the quiz. Not the quiz, the poll. All right. I better stop.